Upsite Technologies, and I'd like to share some information with you, some various considerations around data center supply tiles. It's one of the simplest ways to manage airflow in a computer room, and yet it's often overlooked, and there's a lot of misconceptions. So I'll cover a few details about supply tiles and the types and how to place them, and hopefully this will be something that will stimulate some thoughts on your part, and if you have any questions about it at the end, happy to discuss those with you in person. So before we get started, let's talk just for a moment about why we do airflow management. Obviously, airflow management is an aspect of cooling the computer room. And when you look at the PUE chart for a data center, the PUE calculation for a data center, you see that the cooling of the data center represents a very significant portion of the total cost of operating a data center. That the mechanical plant and the cooling fans represent 35% of the total load, or 73% of the non-IT load. So there's a lot of leverage by improving airflow management to reduce operating cost and regain stranded capacity. So this being a very important aspect of that. So let's look at a number of considerations here. Airflow management is invisible. It's one of the reasons that there's a lot of misconceptions and challenges with managing airflow and optimizing cooling in the data center. We can't see the air moving around in the facility. Also, cooling capacity is difficult to quantify. A lot of cooling capacity considerations are cooling capacity units are used in terms of tons. Well, very few people know what a ton of cooling is, but that's not a problem. All we have to do is convert tons of cooling capacity from the cooling units to kilowatts of cooling capacity. All you have to do to convert tons to kilowatts is to multiply by 3.52, and you convert tons to kilowatts. And then you can compare the kilowatts of UPS load to kilowatts of cooling, kilowatts of rack capacity. My recommendation is convert everything to kilowatts, not kVA, not tons, not BTUs, just convert everything to kW, and then you'll be able to compare apples to apples all day long. There's also confusion because of vendor influence and people marketing hype and various solutions that are looking at one piece of the picture or the other. And this causes confusion in the industry. There's a lack of education about airflow management science and how that builds to the best practices in the industry. So that's one of my goals, is to share the science behind these best practices and help people understand what's going on at a fundamental level so that they can apply those learnings to the room as a whole. There are a lot of different supply tiles, and they break down into a couple of different types. We can look at the construction type and just see that there are perforated tiles, grills, and then there's passive or active. Well, a perforated tile is generally going to have a flat surface. It's essentially a standard solid tile with some number of holes punched in it. These can be constructed in a number of different ways. Doesn't really matter when you're looking at airflow considerations. It's primarily about the open area. So you have perforated tiles and you have grills. Grills generally have a much higher open area, constructed with bars, welded or formed. You look there on the right and you see about 2 down, 3 down is the quad tile. It's one of the most common perforated tiles in the industry. And there's a few other options there with increasing open area. In the center is a highly open grill. These grills can have open areas of 60–70%, sometimes higher as well. And then of course an active tile is one that has fans associated with it that is pushing the air through the tile, pulling the air out of the raised floor, pushing it up above the floor. Depends on how you look at it, where your perspective is. You can purchase tiles with fans attached, or you can buy a fan tray to attach to the supply tiles that you have. Obviously, it's a way to get more air out of the floor. I'd say in general that supply tiles, somewhere around 80% of them were inappropriately purchased, meaning that there was another way to get more air out of the floor. Generally, supply tiles are used when there's cable obstructions that are preventing the air from flowing underneath the floor, or when there's a lot of cable openings releasing bypass airflow behind the cabinets. And all of these things diminish the amount of air that can come out of a supply tile in front of cabinets where you want that air. So sometimes a active fan tile is a really useful tool in a corner of a room where there's a long way from a cooling unit, lots of obstructions under the floor, that sort of situation. They can be really helpful to solve a problem. But remember, a fan tile does not create air. So if you install a fan tile and you get more conditioned air out of that location, there will be less conditioned air out of all the other tiles in the room, or at least the ones in that area. The total will always be the same. The total will equal the total airflow moving through the cooling units. Okay, well, let's look at a few more considerations of supply tiles. Some primary considerations, as I've already mentioned, is open area. And very simply, a 25% open area tile is going to have 1 square foot of open area. 25% of a 4 square foot tile is 1 square foot of holes if you add up all the little holes. And a 50% open area tile, whether it's a grill or a perforated tile, is going to have 2 square feet of open area. Basically, it's the open area that primarily drives how much air will come out of the tile. There's a few other considerations like the construction of the tile and the number of holes. For a given open area, if there's more holes, then there will be less air coming out of the tile than if that same open area is accomplished by fewer holes and fewer larger holes. So that's one consideration. Obviously, load rating is a consideration. Supply tiles are available in different capacities to hold weight, hold load when rolling equipment over them. But this is a commonly abused consideration. When moving heavy cabinets through a room, and if they have to go over the cold aisle, over the supply tiles, then it's prudent to put down some sort of a support structure. Of course, you're going to be blocking, sheets of plywood or sheets of something that are going to be blocking the airflow out of those tiles. So that's a consideration. If at all possible, it's best to move cabinets out of the hot aisle and on the corridors where there are solid tiles. Dampers are a controversial issue with supply tiles. There are some people that advocate absolutely no dampers because they tend to either move on their own through vibration or being loose, or if you give somebody an option to damper the tile, somebody's going to mess with the dampers in the room and cause problems. I would say that that's not a problem of the damper, that's a problem of the management of the facility. Dampers can be very useful because, as with all supply tiles, the goal is to manage the amount of air that comes out of the raised floor to meet the needs of the IT equipment in that area adjacent to the supply tile. So if you don't need as much air as comes out of a tile with no damper, a damper can be helpful, or a different type of tile with a smaller open area. So we'll talk about that a lot more, and that's really what I want to focus on, is the most important aspect of supply tiles, which is balancing the amount of air that comes out of the supply tile with the amount of air that's needed by the IT equipment. Let's look at this chart, which shows us the graph of static pressure versus volumetric flow rate that comes out of the tile. Here's an important consideration. A lot of tile manufacturers using, they're not lying, but they're saying that their tile will supply 1,000 or 1,500 or 2,000 CFM of conditioned air out of the tile, and then you read the small print and it says at a static pressure of 1 inch of water column or 2 inches of water column. Whereas, that's true, but the static pressure differential between the raised floor and above the raised floor is often much, much lower in data centers. This chart shows you that range, from 0 to 6 inches of static pressure. That's a little extreme. Most manufacturers advertise 0 to about 1 or 2 inches. However, you see that red line down at the very bottom of the graph, and that's where the typical pressure is for a data center raised floor. It's somewhere between 0.02 or 0.8 inches, 0.08 inches of static pressure. That is, so that's very little compared to what these tiles are tested for. Let's now talk about placement of perforated tiles, supply tiles. Obviously, the only place that they should be is where the air coming out of them is able to be consumed by IT equipment adjacent to them. So, as you can see in this diagram, this plan view looking at the floor plan of a data center, there's blue and red supply tiles here. Obviously the red ones are not good. Those should not be there. I very often find supply tiles near the door to the data center. The reason for that is often given that the data center manager or somebody at the facility wants the room to feel cool when there's a tour, when the board of directors or somebody is touring the facility. They open the door, they poke their head in, it feels cool. Well, that's a waste of conditioned air. So the only place that supply tiles should be is in front of equipment. But there can be the other problem. There can be too many supply tiles, too much air coming out of the tiles. Again, it's the practice of balancing the supply flow rate from the tiles to the demand flow rate through all of the IT equipment. I find supply tiles in hot aisles fairly often, and been given a myriad of reasons for why a supply tile is in a hot aisle. There's only one sort of acceptable explanation for that, and that's because there's a piece of IT equipment that's turned around backwards and it's pulling its intake air off of the hot aisle. So a supply tile is needed so that it's not cooking, it's not intaking really hot air from the hot aisle. That's fixing the symptom and not the cause. The cause is the IT equipment is turned around backwards, and that needs to be rectified. Turn the IT equipment around, and then that tile can go away. There should never be a supply tile in a hot aisle. There's no need to push the hot air back to the cooling units. Stagnant hot air is fine. The air will make its way back to the cooling units. So let's look a little bit at this bypass airflow consideration and balancing this air. So in this diagram you see that there's 6 units of air supplied to the cold aisle, but the IT equipment only needs a total of 4 units of air. So there's going to be 2 units of bypass airflow flowing out of this cold aisle going back to the cooling units. The right thing to do is to have just a little bit more supply air delivered to the aisle than is required by the IT equipment. That previous example of 6 units supplied when only 4 is needed is fairly conservative. A lot of data centers have not 6 when 4 is needed, but maybe 8 or even 16, multiples, 2-3 times more conditioned air supplied. So let's look at a couple more diagrams that make this clear. And we can also talk about directional tiles here. So directional tiles can be a very useful way to get the conditioned air up at the front of the IT cabinets where the equipment will suck it up. However, they don't solve all problems and they don't prevent problems. So you still need to balance the amount of air coming out of the tile with the amount of air needed by the IT equipment. So we see in this diagram, there's not enough conditioned air coming out of the supply tile. So the equipment in the bottom half of the cabinet or row sucks up all that conditioned air, and then hot air flows over the tops of the cabinets or around the ends of the aisle to make up the difference for what the IT equipment needs. And in this example, here's an infrared image where we see a dramatic case where there's very cold supply air, but it's consumed by the bottom half of the equipment in the aisle. The top half, again, just like that previous picture, is receiving its intake air from over the tops of the cabinet around the end of the aisle. Here's a case where there were problems. They were having a hard time with high intake temperatures in the cabinets, and they installed full containment in this small aisle, and it didn't solve the problem because, again, there was not enough air being delivered to the aisle. So, how much air is needed? Well, it depends on a few things. It depends, well, on two things, really. It depends on the IT load, how much heat the IT equipment is consuming, how much electricity that is. How much electricity the IT equipment is consuming is directly, turns into heat. Every kilowatt of electricity consumed becomes a kilowatt of heat added to the air. So it's the amount of electricity being consumed, and it's the delta T through the IT equipment determines the flow rate through the IT equipment. So we see here there's an example, shows a couple of different examples of, for different delta T's, there's different flow rates. So for a 15-degree delta T, that requires 211 CFM to cool 1 kilowatt of power consumption. Whereas at the other end of the spectrum, IT equipment designed with a 40-degree delta T only needs 79, 80 CFM to cool 1 kilowatt of electrical consumption. So that can have a big effect on the total flow rate that is required by the cooling units. So that's the high-level view. I'll probably cover this topic in additional videos. I want to share this final consideration with you, which is the 4 R's of computer room optimization, computer room cooling. And that's to look at each of these different areas as a project. Look at the raised floor and look at the open area. And that's specifically there's 2 types of open area in a raised floor. Either a supply tile where it should be, or an opening in the floor where the air coming out is not contributing to the IT equipment cooling. So that would be either an unsealed cable opening under the cabinets or a supply tile in a hot aisle or an open area. So look at the raised floor and really quantify what, how many square feet actually. You can just do the math and figure out how many square feet of open area there is in cold aisles and how many square feet of open area there is in all the other locations. And that's a very simple metric for helping manage the raised floor open area. Then you can look at the rack and manage that opening in the vertical plane at the face of all the IT equipment and make sure that that is sealed up. And then, of course, the row and adding containment doors to the ends of the aisles and baffles over the tops of the cabinets to manage the airflow at the row level. And then once any of these projects are undertaken, once improvements are made at any one of these 3 R's, then you need to look at the room configuration. Look at the cooling unit set points, fan speeds, controls, the logic of the cooling infrastructure at the room level to make sure that you're realizing all the benefits possible. So, appreciate your time. Look forward to any questions you may have, and please visit our website for more information about all of our products to help you optimize the cooling in your room. Thank you very much.